Tonight, as your body prepares for sleep, let your mind gently explore one of the most fascinating objects in the universe: black holes. Black holes are not cosmic vacuum cleaners, and they are not holes in space. They are regions where gravity has become so intense that space and time themselves are deeply distorted. To understand a black hole, we must begin with gravity. Gravity is not simply a force pulling objects together. According to Einstein's theory of general relativity, gravity is the curvature of space and time caused by mass and energy. The more mass an object has, the more it bends space-time around it. A black hole forms when an enormous amount of mass is compressed into an incredibly small region. Most black holes are born from the death of massive stars. When a star much larger than our Sun runs out of nuclear fuel, it can no longer support itself against gravity. The core collapses inward. If the remaining mass is large enough, nothing can stop this collapse. Not pressure, not energy, not even light. At this point, a black hole is formed. At the center of every black hole lies a region called the singularity. The singularity is a point where density becomes infinite, and the known laws of physics no longer apply. Surrounding the singularity is a boundary known as the event horizon. The event horizon is not a physical surface. It is a mathematical boundary in space-time. Once something crosses the event horizon, there is no known way for it to return, not because it is pulled back, but because all possible paths forward lead deeper into the black hole. Even light cannot escape. This is why black holes are black. From the outside, a black hole has only three measurable properties: mass, spin, and electric charge. Everything else about what fell in is lost to the outside universe. This idea is known as the no-hair theorem. Despite their reputation, black holes do not actively hunt stars or planets. If our Sun were replaced by a black hole of the same mass, Earth would continue orbiting almost exactly as it does now. The danger lies only in getting very close. Near a black hole, gravity changes rapidly with distance. This creates a stretching effect called spaghettification. An object falling toward a black hole would be stretched vertically and compressed horizontally long before reaching the event horizon. There are different types of black holes. Stellar mass black holes form from collapsing stars and typically have masses between 5 and 100 times that of the Sun. Supermassive black holes exist at the centers of galaxies. They contain millions or even billions of solar masses. Our own galaxy, the Milky Way, contains a supermassive black hole called Sagittarius, a star. It has a mass about 4 million times that of the Sun, yet it is smaller than the orbit of Mercury. Supermassive black holes play a key role in galaxy formation and evolution. They regulate star formation and influence the motion of entire galaxies. Black holes can also merge. When two black holes orbit each other, they lose energy through gravitational waves. These waves are ripples in space-time that travel across the universe at the speed of light. In 2015, gravitational waves were detected directly for the first time, confirming a prediction Einstein made a century earlier. Perhaps the most surprising discovery about black holes is that they are not entirely black. According to quantum physics, black holes slowly lose energy through a process called Hawking radiation. This radiation is extremely weak for large black holes, but over unimaginable timescales, it can cause them to evaporate. A black hole with the mass of the Sun would take far longer than the current age of the universe to disappear. Black holes challenge our understanding considered of reality. They sit at the intersection of gravity, quantum mechanics, space, and time. They remind us that the universe is not obligated to match our intuition. As you drift towards sleep, remember this: even the darkest objects in the universe follow precise physical laws. They are not monsters, they are consequences, natural outcomes of mass, gravity, and time. And while black holes distort space-time, here, in this moment, you are safe, free to rest, free to let your thoughts fade as the universe continues its quiet, endless motion.